So first we are going to write the multiplicative inverse of 4/5. So 4/5, when I use the reciprocal, makes that 5/4. When I multiply this fraction 4/5 by its multiplicative inverse, 5/4 is 20. 5 times 4 is 20. 20 divided by 20 is okay, so we have this problem 4/5 divided by 3/7. What process do we need to solve this problem? So I can't just do 4 divided by 3 and 5 divided by 7, but I can use the multiplicative inverse or its reciprocal. So I would need to copy dot flop. So if I was doing this problem, I would want to keep the first part the same. The opposite of divide is times, so the multiplicative and inverse just means the opposite, 7/3. Then I could multiply the numerators and the denominators. So let's take a closer look at what a multiplicative inverse means. So we have this fraction here, 4/5. If I write the multiplicative inverse of 4/5, I multiply by 5/4. When I multiply this out, 4 times 5 is 20, and 5 times 4 is also 20. 20 divided by 20 is 1. So when I multiply a fraction by its multiplicative inverse, the answer will always be 1. And when I times something by 1, it means it's going to be itself. So when I divide or times by the multiplicative inverse, when I use that copy dot flop, we're getting the same answer. So a multiplicative inverse will always equal 1, which is why we can, instead of dividing, we can multiply. So copy dot flop, and we'll get the same answer. So we're going to solve this problem here, 6 2/5 divided by 4 2/5. Now I cannot just divide as it is. We are not going to get the right answer if we do it that way. We need to see how many pieces we have and then put them into groups of these pieces. So I use an improper fraction or a fraction greater than 1 to do that. 6 times 5 is 30, plus 2 is 32/5. My denominator stays the same. And I'm dividing by 4 times 5 is 20, plus 2 is 22/5. Now I need to copy dot flop. So this is where I use that multiplicative inverse. So we want to do some simplifying by the greatest common factor first. So 5 and 5 have a common factor of 5. 5 divided by 5 is 1. 5 divided by 5 is 1. 22 and 32 also have a common factor of 2 because they're both even. 22 divided by 2 is 11. 32 divided by 2 is 16. So 16 times 1 is 16. 1 times 11 is 11. And then 11 goes into 16 one whole time. 1 times 11 is 11. To get from 11 to 16 is 5 more pieces out of 11. So when I have 6 2/5 divided by 4 2/5, I can make one whole group with 5 11ths left over. Hey, we have Yolanda making friendship bracelets for herself and 6 of her friends. So we've got all those people are getting friendship bracelets. Each bracelet takes 1/3 of a yard. So a bracelet is 1/3 of a yard of string. She has 2 1/9 yards. Does she have enough string to make bracelets for everyone? So see if you can set up what problem you would do to start this and then come back and see what I would do. So I know she has 2 1/9 yards. She has this as her total. And every time she makes a bracelet, she uses a third. So I am splitting up my total into thirds to see how many bracelets she can make. So 2 times 9 is 18 plus 1 is 19 over 9 divided by 1/3. So now I can use the reciprocal, 19 over 9 times 3 over 1. So I'm going to use the greatest common factor of 9 and 3 to divide. 3 divided by 3 is 1. 9 divided by 3 is 3. So now I have 19 times 1 is 19. 3 times 1 is 3. So 3 goes into 19 6 whole times. 6 times 3 is 18. To get from 18 to 19 takes one more piece out of 3. So let's go back and check out our question to make sure our work matches our answer. So does she have enough string to make bracelets for everyone? So the question didn't ask how many bracelets she can make, which is 6 1/3. It wants to know, can she make enough for everyone? So if she's only giving them to her friends, she has 6 friends, then yes, she has enough. But she's also making a bracelet for herself. So she's actually making 6 plus 1 bracelets. She wants 7 total bracelets. So no, she does not have enough to make another bracelet for everyone. She can give them to her friends, but she only has 1/3 of a yard left of string. And so 1/3 of a 9th, I should say. So she does not have enough string to make enough for everyone. She would have to go buy more string to make that last bracelet.